Hi guys, this is Rich again. Imagine you're out having a wild, wonderful weekend with your family in the hills of West Virginia, and at some point you get off trail. Can't find your way back to the car, it's getting dark, and your phone doesn't have any cell signal, which happens a lot around here. Would you know what you need to do to get back to where you need to be? Every year in the United States alone, over 2,000 people get lost in the woods and need rescued. So knowing how to use a map and compass to navigate is not only a great skill to have, one that could literally save your life, but it's also a lot of fun. I've taught this to a couple different groups and we've always had a blast. I first learned how to use a map and compass in the Army, and what I teach is a blend of what I learned in the military mixed with some sport orienteering techniques. The whole idea is to get you up and running and navigating as quickly as possible without bogging you down with a lot of unnecessary detail. This series is going to have about 4 or 5 videos in it. We're going to cover topographical maps, compasses, how to find your position on a map, how to get a bearing, how to plan a route, and how to move along that route using terrain association so you don't get lost again. At the end of each video, I'm going to have a few questions and maybe an exercise or two to help you really get a grasp on the material. So let's go ahead and get started and take a look at the most important piece in your equipment for navigation, and that's your topographical map. So what is a topographical map? Where traditional maps show roads, railroads, waterways, and man-made objects, a topographical map also provides elevation data, or the topography of the land. The way that it does this is with these little brownish red lines called contour lines. And we're going to get into contour lines more in just a little bit and talk about how to tell exactly how much elevation we're looking at and how steep that elevation is. So first, let's look at some of the common things on most topo maps. The map I'm using in this video is a standard USGS topo map. You can buy these maps from the usgs.gov website, and I'll put a link to that site in this description. There's a lot of information in the margin of these maps, and it's all useful, but we're only going to focus on the info you need to get up and running using a map and compass for land navigation. The first thing to be aware of when using a topo map is the scale. This can be found at the bottom of standard topo maps and is represented as a ratio. As you can see, this map is a 1 to 24,000 scale map. This means that every single unit of measure on the map will equal 24,000 units in the actual terrain. In other words, every inch on the map represents 24,000 inches in the world. At this scale, every inch represents 2,000 feet. Most USGS topo maps are in the 1 to 24,000 scale, but 1 to 50,000 is also common. For navigating on foot, 1 to 24,000 is the highest scale you would want to use, and 1 to 12,000 would be even better, because the map would represent less terrain, but it would show much more detail. Another bit of information to pay attention to is the year the map was printed. The older the map, the more likely the terrain has changed, whether it's development, mining, new man-made structures like roadways, or even lakes. These changes can have a serious impact on your route planning. Also, magnetic declination changes over time. We'll cover magnetic declination in more detail in the upcoming video on compass use. But for now, just know that declination is the difference in degrees between true north and magnetic north, and we need to take this difference into consideration when navigating. Okay, so let's talk about contour lines. Suppose you have a terrain feature like a hill or a mountain. It's impossible to represent this in 2 dimensions so that you can understand that it is actually elevated. So what the map makers in topo maps do is they add contour lines to represent vertical distance. So a hill may have contour lines on it like this, and on the map it's represented like this. Now on the margins of your topo map, you'll have a contour interval. That lets you know how much distance there is between each contour line. You'll also have index contour lines on the map, which are a little bit bolder and they have an actual numeric value on there in feet. If we zoom in on a section of the topo map, we can see the contour lines and all the index contour lines. They're the ones in bold with the elevation printed right on the line. So suppose we wanted to determine the height of this hill. We can see that the second contour line from the top is an index line, but it doesn't have the elevation printed on it because the line is so small. But if we keep looking outward or downhill, we see another index line here. And if we follow that index line, we see that its elevation is 1,000 feet. You'll notice that on standard topo maps like this one, every 5th contour line is an indexed line, which means at a contour interval of 20 feet, there's 100 feet between bold index contour lines. Since that's the case, the elevation from this index line to this index line must be 100 feet, which puts the elevation at 1100 feet. And since there's one more regular contour line above it, and we know the contour interval of this map is 20 feet, the height of the hill must be 1,120 feet. If that seems confusing, don't worry, it gets easier with practice. The bottom line is you can tell the elevation of a terrain feature by knowing the map's contour interval and counting contour lines. Now let's move on to identifying common terrain features. One of the easiest terrain features to recognize on a topo map is also one of the most common features in West Virginia, and it's the hill. A hill is represented on a topo map by concentric circles that go up in elevation as the circles get smaller. When you have several hills in close proximity to each other in a line, it's called a ridge, and ridges are represented on a topo map like this. Notice the elevation between hilltops dips a little, but not all the way to the lowest elevation. The low elevation area between two hills is called a saddle, and they look like this on a topo map. Slopes running down from a hill are usually contoured. The higher elevation areas are called spurs and are represented like this. The lower elevation areas sloping down from hilltops are called draws and are represented like this. A low elevation area where the contour lines are spaced further apart represents a valley. Cliffs are terrain features with very sharp changes in elevation. You can recognize them on a topo map when you see several contour lines converging into one or stacked right on top of each other. This is a very important feature to look out for when planning your route because they're impossible to navigate without special equipment. Depressions are sunken areas and are easily recognized on a topo map because they're the only terrain where the contour lines are intersected by small tick marks. It's a good idea to practice identifying these terrain features on your topo map because when it comes time to plan your route, you'll be able to move safely and easily through the environment. Your map will have the different road classifications and the colors associated with them in the margins. And unless stated otherwise, vegetation will be green and water will be blue. Man-made objects are typically black. Okay, so now let's look at a few questions to help you practice using a topo map. Here we go. Topo maps provide all of the information you would find on a standard map, plus A, weather data, B, population data, or C, elevation data. And the answer is C, elevation data. Magnetic declination is A, geographic locations where the Earth's magnetic field is weak, B, the difference between true north and magnetic north expressed in degrees, or C, geographic areas where magnetic compasses may fail. The answer is B, the difference between true north and magnetic north expressed in degrees. This common terrain feature, identified by concentric contour lines, is called A, spur, B, depression, or C, hill. The answer is C, hill. This terrain feature is the lower elevation area between two hills. The contour lines that represent it have a distinctive shape which gives it its name. Is this A, a saddle, B, a ridge, or C, a depression? The answer is A, saddle. This terrain feature is a crease in the land and is usually flanked by spurs. It's called A, depression, B, draw, or C, cliff. The answer is B, this is a draw. Okay, so that covers topo maps and how to use them to identify terrain features and determine elevation. You'll get more practice as we move along through the series. Be sure and check out our next video when we're going to start going over compasses, how to use them to orient your map to the terrain, and also how to find your position on a map using resection. I hope you like this video, and if you do, please like and subscribe, and thanks for watching.